Alright, so let's see how this is going to look in terms of the work that we're going to do with this for the actual assignment. In our assignment, we're going to be asked to graph certain quadratic functions, but we're going to take it in two steps. Step one is we're first going to predict what we're going to get before we actually go ahead and graph it. And by doing that, we're going to save ourselves a little bit of time, because otherwise graphing, we just have to do it point by point, and it takes a while. So let's go through everything first. First off, A. Let's write down what A is, because A gives us important information. In this case, A is -3. And like we talked about at the start of this video, that first off, 3 is greater than 1. It's a bigger number, so that means that our parabola is going to be somewhat on the narrow side. It's going to be kind of thinner, skinnier. Now the negative means that it's also flipped upside down. It's going to be an upside down U shape, which we'll just put a little upside down U right there. So by doing that, we know we're going to get kind of a skinny graph within an upside down U shape. Now B. Once again, from now on we're not looking at B by itself, because A and B kind of work in concert together. And it turns out that, again, we've got our formula that x equals -b over 2a is what's called the axis of symmetry. It's going to tell us where the center of the graph is. So in this case, what we're going to do is we're going to go -b over 2a, which would simplify down to +1. Okay, which means on my graph I'm going to go on the x-axis, because x is 1. We're going to find 1, and we're going to put a dotted line right there. So it tells us our graph is centered slightly over to the right. And then finally we're going to look at C. C is what we call the y-intercept, which we're already familiar with, which is 5. So we know our graph is going to cut through right here, so we'll put a dot. So right away we get a lot of information on our graph. We're going to get a narrow upside down U shape that's centered at x equals 1 and cuts through at this coordinate point right here. So now we can actually do the graphing. And here we have to do a little bit more just step-by-step old school graphing by making a table, XY table. And this is where you just pick your own points. Now, one point we already have. We have the y-intercept at 5, so we can write down that when x is 0, y is 5. So that's 1 point. And now we know it's centered around this line, so we're going to start picking points around here. So let's start off with 1. If I plug in 1, I'm going to get, let's see, x squared, 1 squared is 1 times -3 is -3. 6 times 1 is 6 plus 5. And then -3 plus 6 is 3 plus 5 is 8. So at x is 1, y is 8, so I'll put another dot. And let's say x is 3. Well, 3 squared is 9. 9 times -3 is -27. 6 times 3 is 18. And then again plus 5. So -27 plus 18 is -9. -9 plus 5 is -4. So 3, -4. Now, one other thing that will also help is that we want to have at least 5 points here, but we don't have to do necessarily 5 points of work over here, because the axis of symmetry, the other reason why we found this is because the word symmetry, we know this. It means that things are the mirror image around this line. So that dot I just did, that's 2 over to the right down here. That means there's another dot over here, the mirror image across the axis of symmetry. Same thing up here. This y-intercept of 5, it has a mirror image dot on this side. And so here I get at least 5 points, which is what I want to see in your graphs. I want to see a minimum of 5 points of data. Now I don't necessarily need to see that over here, because we use the idea of the axis of symmetry to give us 5 points, but we need to see at least 5 points so that we can sketch it out. So that kind of, whoops, missed the dot there, saves us a little bit of time. And there we get what we were hoping we would get, which is, again, kind of a skinnier parabola. It's centered around the axis of symmetry of 1, and it's an upside down U shape with the y-intercept of 5.